So the stress strain curve for mild steel. First we need to draw the curve. So here in x-axis we draw strain, and in y-axis we have to assign the stress. The curve for mild steel looks like this, and here we need to divide it into the various segments. A, B, C, C dash, D, E and F. We need to look at each section individually. So let's go through this section OA, or region OA. Here this is the linear region where stress is directly proportional to strain. We can also assign this in this way: strain equals to y into E. So what this y signifies is that y is Young's modulus of elasticity. So this is equal to stress by strain, and more precisely y is linear stress by linear strain, and which is also equals to tensile stress by tensile strain, or compressive stress by compressive strain. In this region, the elastic region is specifically called as proportionality limit. So this region of OA is specifically called as proportionality limit or proportionality region. So this region exactly follows Hooke's law. Now moving on to region 2, that is region AB. Here this region is non-linear, which means that stress is not directly proportional to strain, though the small change in strain is neglected. So this region is also considered as linear region. Here we also use the modulus of elasticity, and summing on all the regions that are OAB, we call this region as linear region or elastic region. This region can be seen in this graph as the region from O, A and B. This region is known to be linear region or elastic region. Here we give the modulus of elasticity as E, which is equal to stress by strain, or linear stress by linear strain, or tensile stress by tensile strain, or compressive stress by compressive strain. So moving on to the region BC. this region is non-linear, which means that stress is not directly proportional to strain. So in this region we can actually see the factor of safety, that is FOS. The factor of safety can be divided into two segments or two factor of safety. The first factor of safety is yield stress by allowable stress, and the second is ultimate stress by yield stress. So where does this factor of safety lies? The first factor of safety lies between the region B to C, where C is the upper yield point and B is actually the working stress or allowable stress. The region C is exactly called as upper yield point, or the stress here is known as yield stress. So this factor of safety lies between the region B to C, and the second factor of safety lies between the region yield stress to ultimate stress. As in the formula we can see that factor of safety is ultimate stress by yield stress. So now moving on to the region C dash, which we have certainly know about from above slide, that is from C to C dash, that is upper yield point, and C dash is lower yield point. So here after C, the non-linear deformation starts to appear, that is known as permanent deformation. Here the lower yield point, that is C dash, is more significant than upper yield point for engineers. Now moving on to the region C dash to D. Here we can simply draw this as the straight line, or this is known as the yield plateau. Here this is the region of constant yield stress, but the strain vary, as we can see from the curve. So here in this curve we can clearly see that strain is being constant and stress is constant, but the strain is varying. So moving on, after this region we go to the region DE. This region is from, as we can see in the curve, as DE region. E is the ultimate stress, and this region is known as strain hardening region. In this, stress and strain increases rapidly due to strain hardening. So what is this strain hardening exactly means? During strain hardening, the ductility decreases and material become harder and so brittle failure. So moving on to the reason 8, that is reason EF. This reason is known as EF, which we can see from the curve. So this reason is known as EF reason. In this reason, material acts like a wire. So this is the original shape of material, that is dumbbell shape. And in this region we can see the material starts to elongate, and this region is necking. After this we go to the fracture point, that is F. In this, specimen gets completely destroyed. So this is all about the stress strain curve. Thank you for watching the video.